Alright, so here we're looking at Pythagoras' theorem. Now Pythagoras' theorem, what it does is it lets you find the missing side of a right angled triangle. So if I've got a right angled triangle like that and I have this side and that side, Pythagoras' theorem will let me work out that side. Or equally, if you have the long side as well, if you know that's 10 and then this is 8, it lets you work out how long one of the short sides is. Now what Pythagoras' theorem looks like, the way it's written down is usually a squared plus b squared equals c squared, where a, b and c are the sides of a right angled triangle from smallest to biggest. So if I draw a triangle like that, the smallest side is a, the middle side is b, and the long side, which is always the diagonal, is c. Now that's the sort of formula, that's what the equation is, but the way that you use Pythagoras' theorem, I prefer thinking of it as a set of instructions. The first thing you're going to do is square the sides. Now, when we look at the formula, we can see that we do a squared and b squared, and we get c squared. So we know that squares are involved, squaring the numbers. So the first thing you're going to do is square the sides. The second thing you're going to do is add or subtract the numbers you just got, and I'll explain how you know whether to add or subtract in a second. And finally, you're going to square root your answer. Right, now, when we're finding, I think I'll just show you a couple of examples, and I'll explain as I'm going along how to know whether to add or subtract. So here is a right angle triangle, we have a missing side, and we're going to use Pythagoras' theorem to work out the missing side. So we know that step 1 is going to be to square the sides. So we're going to do 6 squared, which is 36, and we're going to do 8 squared, which is 64. Now step 2 is to add or subtract those numbers. Now, in this particular triangle, we're looking for the long side. And because we're looking for a long side, it's going to be a bigger number, so we're going to have to add these two squared numbers together. So step 2, we add the sides up. 36 plus 64 is 100. And then step 3, we square root our answer. And the square root of 100 is 10. So the missing side of this triangle is 10. So in the middle of this one, we were looking for the long side, so we added up the squared numbers that we got. But if we were looking for one of the shorter sides, we'd have to subtract. So if, for example, this 6 wasn't there and I'd been given the 10 to start with, then I'd have subtracted my 8 squared from my 10 squared. The next example shows what I'm talking about. This one is going to be a calculator question because a Pythagoras question could be either calculator or non-calculator. But we start the same anyway. We square the sides, so we're going to do 12.1 squared. And I've got a physical calculator. 12.1 squared is 146.41. And we're going to do 5 squared, which is 25. Now, this time we're looking for one of the shorter sides. It's not the shortest side, but if it's not the diagonal, which is sometimes called the hypotenuse, if it's not the diagonal side, then it is a shorter side. So this long one across the bottom, even though it's quite long, is a shorter side because it's not the diagonal. And because we're looking for one of the shorter sides, it's going to be a smaller number, so we're going to have to subtract the squared numbers we got. So we're going to do 146, we'll take the bigger one, and subtract the smaller one. And 146.41, take away 25, is 121.41. And finally, step 3, we square root our answer. So we're going to do the square root of 121.41. Square root is, I'll just give it to one decimal place, 11.0. Now, that we can think about whether we've done it right, because does that answer make sense? You know, does it make sense for this long side, I keep saying long side, this longer side down the bottom here to be 11? And it does. You know, we know it's longer than the 5 from the picture, and we know it's got to be shorter than the 12.1. So 11 does make sense. Right, so Pythagoras' theorem, 3 steps: square the sides, add or subtract your answers depending on whether you're looking for a long side or a short side, and finally square root the number you get, and then that's the missing side. So there are 3 questions there which I'll talk through, but if you'd like you can pause here and give them a try, or just leave it playing as I talk through. So our first question here, find the missing sides of those shapes. Our first one, we'll start by squaring the sides. So 5 squared is 25 and 3 squared is 9. We're looking for a shorter side, even though, like we said before, it's the longer of the 2 short sides. It's still a short side. So we're going to subtract those numbers we just got. So 25, take away 9 is 16. And finally, step 3, we've got to square root that number we just got, which is 4. So I think the answer is 4. Now again, does it make sense? Yeah, it does, because in the picture it looks a bit longer than the 3, but it can't be as long as the diagonal, which is 5. So 4 does make sense. And then this question over here, we'll square the sides. So 12 squared is 144. 13 squared is 169. That's our first step, square the sides. Second step, we're going to add or subtract. This time we're looking for, again, it's a short side, so we're going to have to subtract the smaller number away from the bigger number. So 169 take away 144, which is 25. And finally, we're going to square root that answer. So the square root of 25 is 5. And just like last time, does the answer make sense? Yes, it does. It's a small number, but it's not like ridiculously small. And it is the smallest side that we can see on this triangle, so it's going to be smaller than the 12, so the 5 does make sense. Final question, the perimeter of this triangle. The only reason why this looks a bit harder is because it says the perimeter. It doesn't just say find the missing side, but it's still Pythagoras because we need to know the missing side of a right-angled triangle so we can add the sides together to get the perimeter. Step 1, to find the missing side, we square the sides we've got. So we need 3.4 squared and 1.3 squared. On my calculator, because it's a calculated question, 3.4 squared is 11.56. 1.3 squared is 1.69. We're finding a short side again, so we'll subtract one of those numbers from the other one. We'll subtract the smaller from the bigger. At 11.56, take away 1.69, gives me 9.87. And finally, we square root that number to find the missing side. Right, so that's 3.1417. And that goes on and on. That's a really long number. So if all I needed to do was find the missing side, I'd round that to like 2 decimal places if the question needed me to. But that's the missing side. But remember, for this question, there's a bit more to it because we're being asked for the perimeter. We're not just being asked to find the missing side. So to find the perimeter, I need to take the answer I just got, which is the missing side here, 3.14 ... and add it to all the other sides to get the perimeter. So we'll take that number and plus, I'm going to plus 3.4 and plus 1.3 to get the final perimeter, 1.3. And the final perimeter is 7.84 to 2 decimal places. So that's Pythagoras. The formula you may need to be able to recognize and use, but the way you use the formula is with those 3 steps. You're going to square the sides that you've got. You then add your answers if you're looking for the long side, like we were in our first example in the middle. You subtract the sides if you're looking for one of the shorter sides. And finally, you square root the answer you've got, and then you've got the missing side of the triangle. That's Pythagoras' theorem. Hope that helps.